Hi everyone, welcome to my YouTube channel, Maths Made Easy with Terry in 10 minutes. Okay, we're going to be talking about Pascal's triangle now. And like I told you in the previous video, please, if you don't watch it, you have to go back and have a look at it. What I'm trying to do is I'm trying to lay the basis and foundation, okay, in the previous video. But now we're going to go straight to Pascal's triangle. So what is Pascal's triangle? So Pascal's triangle is, we use Pascal's triangle to expand binomial expressions. So basically, we use this for things like a plus b raised to power n, provided that n must be a positive power. So that means you only use Pascal's triangle for positive power integers only, okay? When you're having negative powers, like a plus b raised to power minus n, or fractional powers, a plus b raised to power n over 5, you can't use Pascal's triangle. You only use Pascal's triangle when the powers are positive. So it's only have positive power integers, okay? Now, for Pascal's triangle, there are 3 rules that you have to keep in mind, okay? There are 3 rules. So that means when you have a plus b raised to power n, so that means the n is positive integers. So the first thing that you have to know is that as we move from left to right, the power of a will decrease, while the power of n will move to 0. So that means as you move from left to right, the power of a will be decreasing from n to 0. That making sense? So as you move from left to right, I'm going to solve an example, don't worry. So as we move from left to right, okay? The power of a, okay? The power of this a. The power of a will decrease or decreases from n to 0. Okay, so as you move from left to right, the power of a decreases from left to 0. Then the second rule is, while the power of b will also increase, so the power of b is going to do the reverse of the power of a. So while the power of b increases from 0 to n. Okay, and the last one, yeah, you can write the Pascal coefficients in front of the terms in order. So that means basically after the power, the a as decreases from n to 0, then the b will also increase from 0 to n. Then after that, you then write the power, the Pascal coefficient in front of them. You write the Pascals or Pascal coefficients, okay, in front of each of the terms. In order that you write it, okay? So the first thing you have to do, okay, this is left, this is to right, okay? So the first thing, as you move from left to right, the power of a decreases from what? N to 0. Is that making sense? Now, while the powers of b is going to increase from 0 to n, then while the Pascal coefficients will be in front of each of the terms in order. All right, before we go any further, there are some key words we talked about. I've said something about the Pascal coefficients, okay? And I've introduced this keyword here. So let's see how do we derive the Pascal coefficients. Then after that, we're gonna start solving some examples on this. So if you look at this, for instance, a Pascal coefficient, this is 1, you put 1 here. So what do you do? So remember, it's a Pascal coefficient for the Pascal triangle. Does that make sense? So you see 1 plus 0 will give you 1. 1 plus 0 will give you what? 1. Can you see? 1 plus 0 will give you 1. 1 plus 2, you write, sorry, 1 plus 1 will give you 2, you write it here. 1 plus 0 will give you 1. You go plus 0 will give you 1. 1 plus 2, 3. 2 plus 1, 3. 1 plus 1, 1. So you can see, as we're going, it's forming a triangle. Is that making sense? So 1 plus 0 will give you 1. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. 1 plus 1, 1. Can you see? Next one. 1 plus 0, 1. 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. 1 plus 0, 1. So as you keep going, you see you can keep going all the way till infinity. And what does this imply? The first one here is for when A plus B is raised to the power of 0. The second one is when A plus B is raised to the power 1. The third one is when A plus B is raised to the power what? 2. This is when A plus B is raised to the power 3. A plus B is raised to the power 4. A plus B raised to the power 5. And you can keep doing this till you get to where you want to stop. A plus B raised to the power n. And this is what we call the Pascal what? Coefficient. All right, so let's solve a simple question first and apply these rules to them. All right, so we have, let's say we have A, let me say A, let me say, okay, let's do A plus B. Let's pick something easy first. A plus B raised to the power 3. And I ask you, for instance, that I want you to solve this question. The first rule says, as we move from left to right, the powers of A decreases from n to 0. So our n here is 3. So we have A, does that make sense? Raised to the power of 3. Okay. While the powers of B increases from 0 to n, then B is going to be raised to the power what? 0. Are you seeing it? So that's it. You keep reducing it. You keep reducing A and you increasing what? B. So the next one is going to be A raised to the power 2. Let me give more space so I can write there. So it's going to be plus. We have A to the power 2, B to the power 1. Can you see? A keep reducing while B keeps on increasing. Plus A to the power what? 1. B to the power what? 2. Are you seeing it? Plus A to the power what? 0 and B to the power what? 3. Are you seeing it? As we move from left to right, the power of A decreases from n to 0. So that means 3, 2, 1, 0. While the power of B increases from 0 to n. So you have 0, 1, 2, 3. Okay? Then after that, we write the Pascal coefficients in front of them. So what is the Pascal coefficient for A plus B to the power 3? This is it. So it's 1. This is Pascal coefficient for it. So it's 1, 3, 3, 1. So 1, 3, 3, 1. Can you see? Then we can then simplify. 1 times 3, A raised to the power 3. Because remember, in the indices, source and indices, you are told that A raised to the power, anything raised to the power 0 is equal to 1. Do you remember that? So anything x raised to the power 0 is equal to 1. So x raised to the power 0 is 1. That means it's going to be 1 times A raised to the power 3 times 1 plus. The next one is going to be 3. Let me use another color so you understand what I'm saying. So we have, it's going to be 1 times A raised to the power 3 times B raised to the power 0 is 1 plus 3 times A raised to the power 2 times B raised to the power 1 plus 3 times A times B raised to the power 2 plus 1 times A raised to the power 0 is 1 times B raised to the power 3. Can you see? And this is going to give you A cubed plus 3A squared B plus 3AB squared plus B cubed. And that will be the answer for that. Okay. All right. So maybe I can pick one more example. Let me just pick one more, just a simple example, and see how we do with that. So let's say I have 1 minus x raised to the power. Let's just use the same 3, or we can use 2, or anyone, or you can use 4, depending on the number you want to use. Okay. So let's use 2 this time. All right. So that is going to be easy. So remember now, we have minus. So it's going to be, the first number is going to be 1 raised to the power 2. Remember, while minus x be raised to the power what? 0. Can you see? Because it's minus. Plus, you're going to have 1 raised to the power 1 and minus x raised to the power what? 1. Plus, you're going to have 1 raised to the power 0 and minus x raised to the power what? 2. So the same thing for n raised to the power 2, the coefficient is 1, 2, 1. So you're going to put the coefficient there is what? 1, 2, 1. So we can then open the bracket now and solve. So it's going to be 1 times 1 raised to the power 1 will give you 1, minus x raised to the power 0 is going to be 1. So remember, anything raised to the power 0 will give you 1, plus 2 times 1 raised to the power 1 is going to give you 1, minus x raised to the power 1 will give you minus x. Can you see? Plus 1 times 1 minus x raised to the power squared will give you x squared. Then this is going to give you 1. 2 times 1 times minus x will give you minus 2x plus x squared. And that will be the answer for that. So you can see that the Pascal triangle is straight up easy. And you can just do, just know that you have the first term, you keep reducing it from power of n to 0. Then the second term will be from 0 to 1. You get the Pascal triangle's coefficients, you add it together, you multiply it and you simplify, okay? What I'm going to do that the next video, I'm going to solve more example on Pascal triangle first, just to add more to this. Maybe we can solve more, a little bit complicated, more examples. Then from there, we'll now go to binomial theorem, okay? So if you have any question, feel free. Let me know. You can put it in the chat or you can email me directly. Thank you very much. And I'll see you in the next video.